Today, we're going to prove that the set of natural numbers is infinite using set theory and some intuitive examples. Let's start by defining the set of natural numbers, which we denote with the letter n. Natural numbers are the counting numbers 1, 2, 3, 4, and so on. Now, let's look at some interesting subsets of the natural numbers. First, we have set A, which contains all odd natural numbers 1, 3, 5, 7, and so on. Then we have set B, which contains all even natural numbers 2, 4, 6, 8, and so on. And finally, set C contains all multiples of 3, 3, 6, 9, 12, and so on. Let's prove that these subsets are infinite. We can do this by showing that we can create a one-to-one correspondence between the natural numbers and each of these subsets. Let's start with the odd numbers. For any natural number n, we can generate the nth odd number using the formula 2n minus 1. This creates a perfect pairing between natural numbers and odd numbers, showing that there are exactly as many odd numbers as natural numbers. Similarly, for even numbers, we can generate any even number by multiplying a natural number by 2. This again shows a perfect one-to-one correspondence. And for multiples of 3, we multiply each natural number by 3 to get all multiples of 3, again showing a perfect one-to-one correspondence. Since we can create these one-to-one correspondences, we know that these subsets must be infinite. And since the natural numbers contain all of these infinite subsets, the set of natural numbers itself must be infinite. This is a fundamental property of the natural numbers. No matter how far you count, you can always count one more, making the set of natural numbers truly infinite.